Today, we're going to talk about one of Apache Spark's most powerful and, let's be honest, sometimes confusing features, lazy evaluation. It's really the secret sauce behind Spark's incredible speed. It's the art of the smart delay. So, have you ever had this happen? You write a bunch of Spark code, you hit run, and it feels like nothing's happening. You're giving it command after command, and it just seems to sit there. You might think it's ignoring you, but what's actually going on behind the scenes is something incredibly smart. We're about to pull back the curtain. All right, to really see this in action, let's work with a simple but pretty big data set. We're telling Spark to create a data frame with a single column, called number, and fill it with all the integers from 0 all the way up to 1,000,000. Seems straightforward, but the real question is, has Spark actually gone and created this data yet? Let's find out. Okay, now let's give Spark our first real job, what's called a transformation. We're asking it to go through all 1,000,000 of those numbers and just keep the even ones. Now, that sounds like a decent amount of work, right? You'd think the computers would be whirring away right now. But here is the crazy part. Absolutely nothing has happened. No filtering, no computation, nothing. Spark basically just took our instruction, nodded, and added it to a to-do list, what it calls a plan. The data itself? Totally untouched. Okay, let's keep going. We'll give it another task. We'll take those even numbers, which remember it hasn't actually found yet, and we'll tell it to create a new column by squaring each one. So now we're just stacking up the instructions, telling Spark what we eventually want to happen. And you guessed it, Spark just updates its plan again. Now it knows it needs to filter for even numbers and then square them. But has it done any of the math? Nope, not a single calculation has been fired off. It's just adding more detail to its blueprint. And let's add one final transformation to the chain. From that list of squared numbers, we only want to keep the ones that are bigger than 1,000,000. So that's our third instruction. We've told Spark to filter, then calculate, then filter again. So this brings us to the big mystery. If Spark wasn't calculating, if it wasn't filtering, if it wasn't doing any of the work we asked for, what on earth was it doing? Was it just being lazy? Well, yes, but it's a genius kind of lazy. So here's the big reveal. It turns out Spark wasn't ignoring you at all. It was listening really, really carefully to every single command. But instead of just jumping on them one by one, it was building a master plan for the absolute most efficient way to do everything at once. This whole strategy has a name, lazy evaluation, and it's a core idea in Spark. It means that transformations, things like filtering or adding a column, they don't happen right away. They just build up a logical plan, which is technically called a directed acyclic graph, or a DAG. Just think of it like a recipe or a flowchart of all the steps you want to take. The actual cooking only begins when you call an action. So the Spark workflow is really this two-part dance. First, you define all your transformations, telling Spark what you want. As you do that, Spark is in the background, quietly building and, more importantly, optimizing its plan. Then and only then, you call an action. And that's the signal for Spark to finally execute that whole optimized plan from start to finish. So what exactly is an action? Well, it's any commands that requires an actual result to be sent back to you. Things like saving a file or showing you the data, or in our case, counting the final number of rows. This .count command is the trigger. It's the moment we finally look at Spark and say, okay, I need the answer now, go. And boom, just like that, Spark executes the entire pipeline. It reads the data, finds the even numbers, squares them, filters for the large ones, and counts them, all in one seamless flow. And the answer is 499,500. This number wasn't created step by step. It was the result of a single, highly efficient execution. So you might be wondering, why go through all this trouble? Why all the planning and waiting? Why not just do the work as we ask for it? Well, because this smart delay, this lazy evaluation, is precisely what makes Spark a total game changer for big data. This whole approach unlocks some absolutely massive benefits. We're talking about incredible query optimization, much better resource efficiency, huge performance gains, and it even makes the whole system more resilient when things go wrong. Let's break those down. This is where the real magic happens. Spark has this brilliant engine inside it called the Catalyst Optimizer. And because Spark waits until it has the entire plan, Catalyst can look at the whole sequence of operations from a bird's eye view.
It can intelligently rewrite the plan for maximum speed. Maybe it reorders your filters or combines a few steps into one. It does all this to make the final execution as fast as humanly possible. And this slide really nails the efficiency point. An eager system, one that does the work right away, would have to create and save a new temporary dataset after every single step. Think of all that wasted memory and disk space. But Spark, with its lazy approach, can often stream the data through the entire pipeline in one single pass, completely avoiding all those intermediate results. Okay, let's distill all of this down into something super practical. Imagine you're in a data engineering interview, and they hit you with the question, can you explain lazy evaluation? Here's how you nail that answer, perfectly and concisely. Here's what you say. Lazy evaluation is a core strategy in Spark, where it builds up a complete execution plan before running any computations. This is powerful because it allows Spark's Catalyst Optimizer to apply improvements across the entire query, not just one piece at a time. This boosts performance by executing transformations in a single efficient pass whenever possible, which saves a ton of resources and makes it much faster. That's it. It's clear, it's accurate, and it shows you really get it. So if you walk away with just one thing from all of this, let it be this. Planning before you act allows for global optimization. By understanding the entire journey before taking that first step, Spark find the absolute smartest, fastest path from A to B. And that kind of leaves us with a final thought, right? This whole plan first, act later model is obviously a huge deal for data processing. But where else is this the secret to success? You see it in software development, in building a house, maybe even in planning your own career. It's a really powerful idea, and it is the secret behind Spark's genius.